Hi, everyone.
Is that Parker? Hi, Parker. Okay. So sum and difference identities. These are, I have to click on here. So these are the identities right here. You do not have to memorize these. I don't even think like once you get to calculus, they wouldn't expect you to memorize these. The ones we did last time, like, yes, definitely, I would have those in your brain. But these ones, just have them somewhere that you can reference. And we use these to find values that aren't on the unit circle, because like we can find the sine of 30 easy. We could find the cosine of 120 easy because that's on the unit circle, or even like the tangent of 180, you could find that easy because those are all on the unit circle. What we're using here, the sum and difference, is when you're trying to find values that aren't on the unit circle. Okay, and as I go through this, if you have questions, just like unmute yourself and ask the question and just interrupt me. Like, it's not rude to interrupt me. That's kind of the name of the game for this online stuff. So here's this unit circle. I can move this. So here's the unit circle. Make sure you have this to reference, because we're going to be using the angles on the unit circle. And it helped me a lot to write down all of these angles, like 0, 30, 45, 60, 90, and so on. So I just wrote down all of the angles that were on here. Okay. And let's say that it asks you to find, and then sine is your y value, cosine is your x value, tangent is y over x. That's another important thing to remember. Sine is y, cosine is x, tangent is y over x. So if we're asked to find the cosine of 105, like if we look at this circle, there's not 105 on there. But we can make 105 by either adding two of them together, subtracting them, and I did it with 45 and 60. But you could do it with like 135 and 30 if you subtracted them. Or, I don't know. I know there's other ones too. Like you can, whatever you come up with, it will work and you will end up at the same exact spot that I'm at. Okay. But I'm using 45 and 60. So I'm just going to write this as cosine of 45 plus 60. That's the same exact thing. This is now just written as 45 plus 60 because we have a 45 degree on here and we have a 60 degrees on here. Okay. And with that, I'm using this, the sum of angles right here, the cosine one. So that's cosine of A, and A is always just the first number. And then cosine of B, which would be your second number, minus sine of A, sine of B. So that would be cosine of 45 times cosine of 60 minus sine of 45 times sine of 60. And then if we look at this, so this is the 45, this is 60. And if cosine is our x value, then the x value at 45 degrees is square root of 2 over 2, which is where I get this right here. Cosine of 60, so the x value at 60 is 1/2, which is where I got that one. Minus the sine of 45, so sine of 45 is the second, so it's the y value, which again is square root of 2 over 2. Sine of 60, the y value at 60 is square root of 3 over 2. And then we just multiply this. And when you multiply fractions, it's just tops with tops, bottoms with bottoms. So square root of 2 times 1 is the square root of 2. 2 times 2 is 4. And then square root of 2 times square root of 3 is the square root of 6. Remember, when you multiply square roots, it's insides with insides, outsides with outsides. So technically there's ones right here. So it would just be like 1 times 1 would be 1. And then 2 times 3 is 6. And then 2 times 2 is 4. And then we have a common denominator here. So we can just make this one fraction. And you get square root of 2 minus the square root of 6 over 4. Okay, and if you check this in your calculator, so if you pulled out your calculator and made sure it's in degree mode, and if you put cosine of 105, you would get the decimal equivalent of square root of 2 minus square root of 6 over 4. Okay, and that is your final answer. Is there any questions with that? We're all okay with that. Okay, I'm just going to assume since no one said anything. So then sine of negative pi 12ths. I don't like working in radians because it's like my brain, it just doesn't work in radians. So I'm going to convert this 2 degrees first. And remember to convert to degrees, you multiply by 180 over pi. So those pi's cancel. 180 divided by 12 is 15 since it's negative. This is the same as sine of negative 15. Okay. And then we can find 2 values that they have to subtract because that's the only way we're going to get this negative, but subtract to be negative 15. And there's lots of them you could use. I'm just going to use 30 and 45 because 30 minus 45 is negative 15. And if you struggle like getting the negative, find 2 that will subtract to give you 15 and then just switch the order. So like 45 minus 30 is 15. So if you flip the order, 30 minus 45 would give you the negative 15. So then this is the same as sine of 30 minus 45. So that means we're using this difference of angles right here. And this is not a negative 45. This subtraction takes into account like the negative part of this. Okay, so don't do negatives. We don't deal with negative angle measures when you're looking at like just your basic unit circle. So then this is going to be sine of the first one, so sine of 30, times cosine of b, so cosine of 45, minus cosine of 30 times sine of 45. And then this is our 30 degrees, this is our 45. Sine is your y value, cosine is your x value. So the y value at 30 is 1/2. The x value at 45 is square root of 2 over 2. The x value at 30 is square root of 3 over 2. And then the y value at 45 is square root of 2 over 2. And then we can just multiply. So then that's going to be 1 times the square root of 2 is square root of 2. 2 times 2 is 4. And then minus square root of 3 times square root of 2 is square root of 6 over 4. Which you get square root of 2 minus square root of 6 over 4. Which I think that's the same as the last one. And a lot of these do end up the same. Most of the time, you're going to have a square root of 2, a square root of 6, and a 4 in there because of the values of this unit circle, because we have square root of 2s and square root of 3s. Okay. It's just like sometimes they'll both be negative, sometimes they'll both be positive, sometimes only one will be negative. Okay, is there questions with that one?
Wait, so did you say that one was over 4?
Yes.
Why is it 4 instead of 2? Because weren't they both over 2 before?
It's because, so right here, we multiply 2 by 2. So 2 times 2 is 4, which is where we get the 4 from, and then it just stays.
Okay, thank you.
Yep. Any other questions? Okay, let's do a tangent one. So the tangent ones are probably the harder ones. So if we have tangent of negative 165, again, you can find 2 that will subtract to give you 165 and then just switch the order. So I use 210 and 45 because 210 minus 45 is 165. And then just flip that order. So if you do 45 minus 210, you get negative 165. And there's probably other ones you can use. Again, it doesn't matter, just as long as like this is the same as this. Okay. So then we're going to use this tangent of a minus b. And then we have the fraction, which is what makes this a little bit harder, is that you're dealing with a fraction in here. But that's tangent of A minus tangent of B. And again, this is not a negative 210. This subtraction like takes into account for that. And then over 1 plus tangent of A or times tangent of B. So that's tangent of 45 minus tangent of 210. And then 1 plus tangent of 45 times tangent of 210. So then I'm just going to find 45, and 210 on my unit circle, which is why I put a link to the unit circle. I don't remember if it's on the video page or the homework page, but there is a filled out unit circle on there in case like you lost yours or something. But tangent here is y over x. So if we do y divided by x, let's find the tangent of 45 first. Okay, so the y value there is square root of 2 over 2. The x value there is also square root of 2 over 2. Well, anytime you have something divided by itself, it will always equal 1. So the tangent of 45 is 1. And then if we find the tangent of 210, so that's the y value here is negative 1/2. The x value is negative square root of 3 over 2. Notice, and I think I went over this a little more in the video, but if you have the same denominator, like you have a fraction inside a fraction and they both have the same denominators, well then these denominators can just cancel and the negatives are also going to cancel. So I'm just left with 1 over the square root of 3. Okay, and for our purposes, I don't care if you rationalize that. Like if you do rationalize that, awesome. If not, we can just leave it. It's not a super big deal to rationalize right now. Okay, is there any questions with this? Okay, so then I'm just going to plug these in. So tangent of 45 is 1, so I'm going to put 1 right there. Tangent of 210 is 1 over the square root of 3. And then 1 plus tangent of 45 is 1. Tangent of 210 is 1 over the square root of 3. So then I can simplify this a little bit further. That's 1 minus 1 over the square root of 3. And then 1 plus 1 over the square root of 3. Now I just need to get rid, like I don't want fractions inside of fractions. So we just need to simplify this further. If we get a common denominator here, so we can change 1 to be square root of 3 over square root of 3. Because that's the same thing as 1, we're just making it look a little bit different. So if I do square root of 3 over square root of 3 minus 1 over the square root of 3, and then same thing here, I'm going to change this one to square root of 3 over square root of 3 plus 1 over the square root of 3. And then on top, since we have this common denominator, I'd be left with the square root of 3 minus 1 over the square root of 3. On bottom, I'm left with square root of 3 plus 1 over the square root of 3. And then same thing that I was doing right here. Since we have this same denominator on top and bottom, that square root of 3 can just cancel. And so I'm left with square root of 3 minus 1 over square root of 3 plus 1. And if we were in school, like, and I was there to help you guys through all of this, I would make you rationalize this. But since we're not, just leave it right here. And then you're done. Okay. These ones are a little bit, like, I've always thought these were a little bit easier just because you're actually working with numbers here. I'm also like I like numbers versus symbols a little bit better. But is there questions with that?
So with this whole concept thing, is the goal of this trying to find out what the tangent of negative 165 would be or what the cosine of blank would be?
Yes, yeah. So say like, here, let's see if you can. If you used your calculator right now and you put it in degree mode, if you put the tangent of negative 165 in there, you would get, here, I'll just do it in my calculator. So if you put tangent of negative 165, you get 0.2679. This is just like the, this is also going to be that same exact number, but it's not going to be like the decimal equivalent. It's going to be the actual number. So if you did square root of 3 minus 1 over square root of 3 plus 1, you get that same exact thing. I don't know if you can see that, but it is the same exact thing. So that is the goal, is to find what like the tangent is or cosine or whatever.
Okay.
Okay. Any questions on that?
How come the tan 45 just equals 1?
It's because, so if you look at 45 degrees right here, tangent is y divided by x. So since the y value there is square root of 2 over 2 and the x value is square root of 2 over 2, if you divide something by itself, so you end up doing square root of 2 over 2 divided by square root of 2 over 2, that cancels since we have the same thing on top and bottom, so you're just left with one.
Okay.
Any other questions on this? Okay, that's basically it. And then for the assignment today, I didn't know how to do this online. Like, I think the best way to do this is on paper. So if you go to, oh, and if you're having trouble like finding the videos, I post the Google Meets right here. So it's just underneath what like the actual video was. But if we go to, so day 2, here's out the filled out unit circles. So you can click on that and then you can print it out or whatever, just have it there to reference if you lost yours. And I'll post the video down here. But here is the assignment. So just download this assignment. And this would be the assignment we would have done in class also. And it kind of, like the format's weird. I'm sorry about that. So you can either print this out or just do it on a separate sheet of paper. And then when you upload it, yours looks different than mine, but you can just upload the picture of it, or if you have a scanner or whatever, upload that. But just upload a picture of your assignment, and then that will be it. And I will post the answer key to this tomorrow. Okay, I want you to go through it first, make sure you like are trying these, and you can always send me them to like, if you get stuck or something, email me and I will just email you back and see where you messed up. But I will post the answers to this tomorrow. And I posted the answers to the assignment last time. If you go to modules and you go clear down to unit 11, the Pythagorean identities answer key, it's just right here. So you can see if you want to double check that you did that right. But that's pretty much it. If you have questions, you're welcome to stay on and ask questions. I'll probably stay on for like 10 more minutes unless everyone gets off. But that is pretty much it. I'm going to stop recording this.